Swayam Prabha. Digital India. Educated India.
So, let us get on to the next term, which is the joint probability. So, now we have defined what is an event. So, now we want to find out whether the two events can be combined to get one more probability number. For example, I want to combine the probability of the event D and the probability of the event pack. So, it is defined as in a set notation as given in 2. Okay. So, this is called as the joint probability of E1 and E2. The probability E1 and E2 occurs simultaneously. So, if we will now define or try to explain this with respect to certain examples. Okay. So, here the probability of the first letter T and the probability of the second letter H is probability of F equal to T comma S equal to H. So, this is the joint probability, and this probability should be as large as the probability of the event probability D. Okay. So, next we will define the conditional probability. In many cases, right. So, you know certain input with respect to what we are going to be doing as an experiment, right. So, we have some a priori knowledge or partial knowledge about the outcome of the experiment, and that we want to use in our probability experiments. Okay. So, we define the conditional probability as the probability of events E2 given that E1 occurred. Okay. That means, the E2 occurs only when E1 has occurred. So, it is defined as the joint probability that we had seen earlier, and in the denominator we see the probability of that event alone, which you know a priori. Okay, let us take a small example of conditional probability using a bigram. Okay, I am sure you know how bigrams are formed. Given a document, you take two words at a time. Okay, you just move the window which contains two slots, and then you move continuously over each word, and then you get a set of bigrams. I have taken a corpus where kinematics problems are available, and there are about 280 problems there. It is a very small corpus, and the bigram samples are around 3767. So, I have taken 2 words at a time, and then I counted that, and this is what we have. So, that is your sample space. Okay. So, now we want to find out the word starting with average and the words ending with speed. Okay. So, let us get a set where average is used as the first word. Okay. So, we get the bigrams and then get all the bigrams that start with average, and the second could be anything. Okay. In the same way, we get another set where speed is used as the second word, and any word could be part of the bigram. That means, it is mandatory to have speed as the second word, and then the first could be anything. So, when you have two such combinations, there is a possibility that there is the average speed may occur Okay. In this set, let us assume that this is the average star, this is the star speed. Okay. So, there is a chance that we could get A and S here, right. So, in this case, since it is talking about the kinematic problem, so there are situations where these two words are available as part of that. You get the probability for the word average. Okay, you have the word average and then you have the entire tokens available, and then find out what is the probability of that word, from by distributing that probability mass of 1 across the entire token set. Okay. In the same fashion you get this. So, if you look at these two words, the average and speed, speed occurred more number of times than average. Okay. So, that means you will find this particular set bigger than this set average. Okay. So, let us find out how many times average and speed occurred together. Okay. So, you get this number again from the bigram value. So, you go and then find out and count how many times the average and speed occurred together, and then that is equal to 0.004. Okay. So, now going to be finding the conditional probability of the average being the first and speed being the second word. So, now I have the joint probability, and now I have the count of the word or the probability of the word average, and then you remember it is the ratio of the joint probability to the probability of that word that occur as the first one. So, we have average speed has the probability of 0.111. Okay. So, let us find out whether it is the same when speed occurs as the first word. Okay. So, in this case again we know this, and we also know the probability of the speeds, and then if you look at the value, it is smaller. That means you will find more of average speed than speed average in the given document. So, this is how we familiarize with the structure in the document and this sentence. For example, if you are asked to construct a sentence and then you are given a sentence like find the speed average, you are likely to come back and then say that this is not the right formation and this would be the right formation of the sentence based on what we had seen here. Okay. So, we have some information about these bigrams, and then using the bigram logic and the information that is available to us with respect to the probability, we find that the particular sentence find the speed average need not occur in this, but the right sentence could be find the average speed. So, in this way we will be able to find out whether the given sentence is the right sentence or wrong sentence. Okay. So, let us take another example of a trigram. I am taking the same corpus, it is very small, but in this case now I have taken 3 words at a time. So, now I am forming the trigrams. So, I use the window size with 3 slots and then move the slots along the document, and then I am capturing all the trigrams. So, this space is now containing 5902 trigrams. So, if you remember the previous case for the bigram, it is only about 3767. So, now in this case it is 5902. So, as you increase the gram from 2 to 3 to 4, the sample space would increase. You also would see that the complexity is increasing slowly as you increase the n-gram size. So, in this case what we are doing is we are taking two words as occurring together like what we had seen average speed, and then we want to find out what is the third word that is going to occur after average speed. Okay. In this case, now we capture all the trigrams that starting with average speed. I am restricting my size here. Okay. And then I am going to find all the trigrams ending with off. So, it is not going to be just average and speed, it is going to contain any other word here, right. Just to show some idea, I have just used those two words again. Again, we are going to find the word for the same operation. Again, I am doing the same operation. So, now we have about 4 sets. This is a trigram ending with during. Okay. So, we have also found that the average speed has occurred and that is the probability, and then the probability of these 3 occurring together is 0.0007, and then all the 3 words along with for as the last one we have the probability, and then for the word during along with average and speed this is the probability. So, now we want to estimate what would be the best example or what is the trigram that most likely to happen with these 3 words. Okay. So, in this case again as we have done in the earlier computation, we are going to be computing the conditional probability where average and speed is known, right. So, if you use the formula for the conditional probability, we are getting the probability of the word of occurring after average and speed is 0.21875, and for the word for it is 0.15576, and for the during this is the. So, now what would be the most likely sentence if you use average and speed? Okay. So, find the average So, we can say that off is going to be the most likely to occur. Okay. So, if you draw the graph like we had seen in the earlier case, I am going to be using a bar chart. So, we will have for here, and then we will have I am sorry, this is off, this is for, and this is during. Okay. So, given the knowledge that this is how the probabilities are available. So, the most likely word that we will pick is off. Okay. So, I wish you have understood the concept of conditional probability with respect to what we are doing in the natural language processing. Okay. Let us move on to the next one. See, for example, in many cases, right, we have seen certain words occur together. For example, New Delhi, New York, Hong Kong, and so on. If you look at the cities, they do not happen by chance because they are the names of the cities. In the same way, there are certain words that always happen together. We want to find out how often they occur together, and then do they really happen by chance, or is it because of the number of time they occur, they always occur together, and we have to use them always as a set of words. If you look at the examples in the case of newspapers, the Hindu, right, Times of India, Hindustan Times. So, even though all these words are different, they are going to be occurring together if you are talking about newspapers, right. So, we need to find out whether these words in the given corpus occur as a chance. So, we have to find out whether they occur by chance or they are dependent on each other, right. So, in some way or other, since the machine is going to do the job automatically, we have to give some kind of tool so that it identifies certain words that are always together. So, we can probably use the idea of independence in some way. And there are also other mechanisms available. It is a very simple rudimentary approach. I just want to explain the concept of independence through that. Two events are dependent, then the probability relies on the occurrences of either one of those, right. So, we have seen that in the conditional probability, and if they are independent, then the probability of those events would be the multiplication of the probability of individual events, okay. Or in other case, we can say that the probability of the event E1 is not really affected by the condition that we have here, okay. Even in this case, it is not really affected by the condition here. So, let us take the example of average and speed. Like we had seen, the probability of the average is 0.036 and the probability of speed is 0.114. Do they occur by chance? Okay. They do not occur by chance. If you look at it, they occur as a pair, hence they are not independent events, they depend on each other.